Hello, Ocular Zombie, welcome. Oh dear, my bitrate just died. Let's see, hold on. One second. Okay. Looks like we're back. Welcome to the stream, Ocular Zombie. Glad to have you here. And also, I have a light right here that's like blinding me. But it's necessary because I'm literally underneath my bed right now. I have like a loft set up. But yeah, let's go ahead and lower the volume a bit of the music. Okay. And yeah, let's just wait for maybe a few more people to come in and we'll get started. And I actually had to shave right before the stream too, so I was hoping to go online a little bit before 2 o'clock, but it seems like I just made the planned time, so alrighty, and let me check out how the announcement looks in the Discord. Very good. Okay. So you guys let me know in chat if my stream just drops suddenly so that I can fix it. Otherwise I don't really know because I don't have my headphones on or anything. So I don't know when I get like the errors or whatever. Alright, let's get started. So, welcome back to the Project Euler First 100 Problems Challenge. I will be writing all of my solutions in the F# programming language. And as you can see, we already have the first 7 challenges done. This last one we did was listing the getting the 10,001st prime number. And as you can see, that was really easy to just implement real quick. It was only a few lines of code. And yeah, let's go ahead and start with our 8th problem. So I'm just going to add some markdown here. Let's see if it'll let me drag it up. Apparently not. So I'll just remove this one. Okay. So this one reads the 4 adjacent digits in the 1000 digit number, and the 1000 digit number for reference is this monster right here. Hold on. There we are. So this is the 1000 digit number. And we need to find, let me just paste it in here. We need to find the 13 adjacent digits in the 1000 digit number right here that have the greatest product. So it gives an example here, 9 times 9 times 8 times 9. Those are the digits that are adjacent to each other that have the highest product in this set here. So let's go ahead and start working the problem. Okay, so let's check that in. And also, I forgot to put the header. Challenge number 8. Alright. Perfect. So now let's add some code here and save our file. Alright, so let's start by defining this monstrous number as a constant in our code. So I believe I can do this. Let's see. How do I do a multi-line string? I suppose I can do it this way. This will take a little bit, but we'll get there. Let's see. Yeah, there's not that many lines to do, so it's fine. And let me just check OBS here, just to make sure that everything is going good still. Okay, perfect. Almost there. Just 5 more to go. Oops. So the reason I'm making this a string is so that I can parse it. Or actually, I don't even need to parse it as an integer. It's actually more useful in string form. Okay, so let's let big num equal this. Whoops. And I'm just indenting all of these lines. Okay, perfect. So that's that. And now let's write a function that basically loops through this and gives us a set of all of the 13 adjacent digits. So how I think I'm going to do that, actually, let me just look this up here. Sequence F sharp. So I think there's like a chunking function which should do what I want. Let's see here. Group by. Have I been muted this whole time? Oh lord. Okay. No, everybody. Been having some technical difficulties, but yes, I'm back. I don't know for how long. I might have to lower the resolution of the stream, but I want to be stubborn about that and see how hard I can push that. So yeah, welcome back everybody, and let's get back to the coding. So yes, welcome back everyone, and hello to all the new viewers, and yeah, let's get right back into it. And I'm gonna just stop the replay buffer in case if that's the cause of the issue. And I might also stop recording on my end, because it's being recorded on YouTube. Okay, so let's get on with it. So what I was trying to do before I was so rudely interrupted by the issues is effectively take in a sequence of numbers, or of digits. In this case, that's what this is. And effectively what I want to do is output a list of all the 13 adjacent numbers that I can create out of this longer list of digits. So what I'm gonna do in order to do that is something like this, and I'm just gonna go ahead and mute my speaker here. Or actually, let's see. Yeah, okay. Sorry, I'm getting distracted. So how I'm going to do that is effectively by doing sequence.take, or actually skip, and then I'm going to do we're going to take in the sequence. So we're going to skip the first I elements of the sequence, and then what we're going to do, yes, let me pop up the chat as well. Okay. So put that there. Whoops. Okay, perfect. Alrighty. So then next what we're going to do is take n, we're going to take n elements. And I think that should fix it, maybe? What does sequence.skip say? Okay. So that should be correct. Okay. So next I'm going to input our number 13 and big num, and we're going to see what this outputs. Alright, perfect. So this gives us the result we want. It gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 adjacent digits, and it's kind of like, you see, it's like a rolling window through our sequence. And what we're going to do now is we're going to pass this to sequence.map, and we're simply going to map it to the integers. And that's basically going to convert it to integers. Then oh wait, hold on. I actually have to do this 2 layers deep, which is interesting. So let's go ahead and implement that. Okay. And then we're going to do the following. We're going to map all of our sequences to sequence.map. Actually, we're going to do a lambda function here. So we're going to take in a sequence. We're going to pass that sequence to another mapping. Actually, let's see. I believe we can fold. Yeah, we can do a fold here. So let's do a fold. Oh, there's actually a map fold function. Okay. So that makes it easier for us. And we're simply going to do multiply. There we go. So I believe map fold. Yes. We also need to put in an input state, I think. So what I'm wondering is, does the mapping come first? No, it doesn't. Okay. Oh, I suppose we can do... Oh. Okay. So it's... What we're doing is a map a fold map, but I got confused. Okay. So back to what we were doing then. So we're taking a sequence and we are doing sequence, passing it to sequence.fold, and simple as that. Just passing in the multiplication function. And then an initial state. So I believe this should give us something close to what we want. Okay, we're getting some interesting results, some negative numbers, which doesn't make much sense, but I believe that's actually some overflow that's going on. So how we're going to fix that is by converting to 64-bit integers. And even then, we get some negative values. So perhaps what we need to do here is... Wait, let's see. Does this make sense? Let's actually take this and compute the sum ourselves. Alright, so I'm just going to pull up my calculator here and do 7 times 3 times 1 times 6 times 7 times 1 times 7 times 6 times 5 times 3 times 1 times 3, then times 3. Okay. So let's put this back in here now and see what the results are. Okay, so clearly something is wrong here. Let's see what it is. So I'm gonna pull up my documentation here. So we have fold. Okay. So this part here might not be right. So let's debug this first. Yeah, that's the part that's giving us weird stuff. The question is why? Oh, okay. We want to do this. First string, and then int 64. And maybe I can reverse these? No, that wouldn't make much sense. Or actually, yes. Okay. So let's try this now. Okay, that's even weirder. Okay, there we go. Perfect. So we have that. Now let's paste in the rest. Okay, nice. So now I do wonder if I could have done a map fold here and just done this. Okay, then 1L. Yeah, so that's the opposite of what I want to do. Okay, so now all we do from here is take the maximum. And we'll do what it's recommending here, truncate, just to fix this. Okay. So that is our result. Alrighty. So let's go ahead and check to see if this is correct. So I'll go to projecteuler.net. And we will paste this in. And that was correct. Awesome. So that's our first challenge of the day completed. And now we'll make a new file. Whoops, .dib, and we'll keep on going. So the next challenge then is challenge number 9. So this one is this. So it's a really simple one, well, seemingly simple. And let's change this to Markdown. And we'll do challenge number 8. Alright. So there exists exactly one Pythagorean triplet for which a plus b plus c equals 1000. Find the product ABC. Okay. So this actually seems like it might be a slightly more difficult one. So let's just do this right here as well, just for some helpful context that might help us with the problem. Okay. So there we are. And we'll just click that check mark. Okay, so let's change that to F# now. And let's try and get a handle on the problem. So here's the way I'm thinking about it right now, is that perhaps we can use this a less than b less than c to basically brute force the problem, but do a little less work than what we would have to do otherwise if we were trying all of the combinations. So of course, so if we're starting with 0, and the next natural number is 1, and the next one after that is 2, so the lowest sum we can make is 3. Going based off of this a plus b plus c. So effectively what we want to do is go through all of the numbers a and b that when we add the c that we find from them to their result, we get 1000. So yeah, I think that's enough to get started. So the smallest then, what's the smallest Pythagorean triple then? I think that's 3, 4, 5. So yeah. Okay, so the sum of 3, 4, and 5 is 7 plus 5. That's 12. So the lowest sum we can make is 12. I believe. Yes. So if the lowest sum is 12, yeah, so we shouldn't have to check anymore from 3 to 50 on the first one, and 4 to 50 on the second number. So let's see. I actually have code for this. Let's go to a previous challenge. Okay, so this is our naturals. So let naturals be this, and we'll let possible a equal naturals passed into sequence.take, or actually .skip 3, and sequence.take, and we'll do just 50. And we'll let possible b equal, excuse me, 4, and we'll take 49. Oh, these should be 500 and 499. Okay. So now let hypot for hypotenuse, we'll take in a and b, and after that we'll simply do a squared plus b squared. Simple enough just to multiply by itself as well. And that's about it. So that's simple enough. And now we'll do sequence.map to, and we'll take in possible a, possible b, and we'll do hypotenuse. No, that's not what we want to do. So we'll take possible a, and we'll do sequence.map, and in this we'll do a sequence.map No, okay. So basically I want to do a nested loop where we loop through all of the possible A's and all of the possible B's and multiply them and do the hypotenuse function, and then we output each of those triplets. Okay. Oh yes, and this should be pass to math.square root. Or actually, I do believe there's a square root function. Okay. And then we'll pass that to integer. Okay. So that'll give us the C for all of our A and B pairs. So let me actually look at map 2 here. Yeah, okay, so that's definitely not what I want to do. So what we'll do is this. So we'll get an A, and then we'll pass possible B to sequence.map, and then we'll do a function in here, and then simply enough we'll do hypotenuse of A and B. And I think this should be in parentheses. Okay. So now all we have to do is output our triple. So what we'll do is this: A, B, and then hypotenuse of A and B. So let's output that. Oh dear. Okay. So that should make it better. Not quite. So let's try this again. Yep. Welcome, Linturni. Hello. Yes, everything is fine now after the reboot. Everything seems to be working alright. Thanks for coming. But yeah, right now I'm just trying to work this problem here. So yeah. Oh, okay. Yeah, I'm having trouble understanding what my code is doing here. I've created a problem of my own design, it seems. So, is 3 times 3 plus 5 times 5? Okay. Oh, okay. So we want to basically discard anything that isn't an integer. So let's go ahead and do that. So we'll filter. If I don't understand my own code, then you can't help that much. Well, that's fair. Yeah, I don't expect a lot of help from chat. It's just mainly me working through these math problems and just having fun with it. So yeah. suffice it to say, I'm glad you're here watching. So what we'll do here is take in a function. Let's actually do this. So let's let instead triplet be A, B, and then this. And then we can shorten this up by saying triplet. Whoops, there we go. And then we'll do let is integer n equal, or actually we'll take in x. And if we do, let's see, x cast to integer equals x. There we go. So then all we do is filter by is integer. Or actually, I do have to encapsulate this. A, B, C. And then do is integer C. Yes, fortunately I can undo and redo as I please, and I'm a very large supporter of the save early, save often methodology. So I think I have things covered, but thank you for reminding me. There we go. So let's try this. Okay. So what's this doing? Okay, that makes sense. So we'll do this as float. All right, and this should work. What's this? What's the type of this? Yeah, so this should run now. Oh, okay. So if I do instead floor, this should get me the result I want. So that's that error taken care of. And then you'll be right back playing the complete saga in Windows XP mode. Awesome, sounds good. See you in a little bit. So if triplet is giving us, yeah. Wait a second. I think I know what's going on here. No. Yeah, this is really bizarre. Can I not pattern match on this? Oh, okay. So, the solution is actually really simple. So what I'll do is So actually it might be easier if I let off on making it a tuple until later. So we'll take in x, and we'll make this hypot. Okay. So then we'll make this x, and then we can just make this is integer then. Then we'll do another mapping, and that's where we'll make our tuple. So then, all we do is A, B, and C. Okay. So if I do this, and then this, does that fix it? Oh, okay. This is actually kind of an interesting problem, the way this is happening. I'm wondering what I could do to kind of simplify this, because I feel like I'm overcomplicating it slightly. So what I believe I can do right off the bat just thinking for a second. Okay. So it actually isn't as complicated as I think it is. So we'll do B hypotenuse A. So actually we'll do that there. Okay. Then is integer. So let's compile this now. Okay. So that's better. Now we can simply do second and then pass that to is integer. Okay, and let's break this up a little bit. So indent that. Just to kind of make this a little bit more readable. I should have done that like ages ago. Okay. So then we can take in our tuple. So this should be BC. And now I think, yay, there we go. Perfect. So this gives us all the triples. So now what I think we should do is have it return the sum of each of our triples. Oh, and yeah, that makes sense. Actually, I'll do it like this. There we go. So these are all the sums then. Now, all we have to do is figure out. So A, B, C, then the sum. Okay. So we have 3, 4, 5, and 12. 5, 12, 13, and 30. And so on. So then, given this, we need to do now a sequence.find. Then we'll do A, B, C, sum. Sum equals 1000. Okay, interesting. Oh, okay. So, I believe what we can do here now is sequence.collect. No. We want to do that at the highest level. And that fixes our issue. Okay, so we have our Pythagorean triple. And let's just verify that this is a triple. It should be. So if we do 200 times 200 plus 375 times 375. Whoops, I did that wrong. Okay. So 200 squared plus 375 squared. And then we'll do the square root of that. And that is indeed correct. Okay. So now we'll let A, B, C, and underscore equal this. Then all we have to do is A times B times C. And let's indent all of these. Perfect. And why is that? Oh, yeah. Okay. Right, because that's a float. So let's do int64c for all of that. And there we go. Easy as pie, as they say. Alrighty. So let's go ahead and submit our answer. Alright, awesome. So that was correct. So let's see what the next one entails. One second, let me go back to problems. Summation of primes. Find the sum of all primes below 2 million. Okay. That should be pretty easy. Alright, let's try it. So, just to recap for anyone just joining in, so we basically just solved a problem where we were trying to find a Pythagorean triple whose sum was 1000 and then take the product of those three numbers. So if that means anything to you, congratulations, you have a high school education. Yes, so let's go ahead and do number 10. So just gonna pop this up here. Copy and paste. Challenge number 10. Paste that in. Perfect. Okay. So now we'll make this F sharp and we'll give this a go. So we already have code that gives us the prime numbers. This is easy enough to do, so let's just copy and paste that. And now let's go ahead and find this sum. So we'll do sequence.take while. So we'll pass in primes. And we'll do 2 million, or n less than 2 million. And we'll make that a 64-bit integer. And I believe that should be correct. Okay, perfect. Now we just take the sum of that. Awesome. That was easy. All right. So let's go ahead and submit that and see if it was correct. Alrighty. Perfect. So we just finished the 10th problem. I think it's worth considering taking a little break. I think maybe it'd be fun to play a game real quick just to take a break from the coding. Because I don't know about you guys, but I've been at it for almost an hour now. And I'm a bit sick of writing code right now. So yeah, I think I'm just gonna go ahead and pull up a game. I think that'll be fun. And we're not done completely with coding today. We'll probably hop back into a couple more problems before we finish off, but I just think it'd be fun to play a game for a bit. So stay tuned if you're just joining in, and yeah, let's have some fun. Oh yeah, I gotta mute myself. Okay. Bye-bye. Or 1 second, I'll be right back. Alright, I'm back. Okay. So, yeah. Let's go ahead and pull up a game. So, I think it would be fun to play Marble Blast Ultra. So I'll go ahead and start that game up. Let's see here. And perfect. Okay. So I'm just gonna go ahead and add my face to this one as well, because I haven't set up the game stuff before for this streaming setup. Okay, perfect. Alrighty. So, you should be able to see the game now. And I believe, yes, game has audio. And I'm gonna go ahead and play the music from the game. So I'm just pulling that up real quick. Okay. Okay. Perfect. And we'll put this through with the PC audio. Oh dear, that is a bit too loud. Let's see how my levels are. Oh yeah, that's way too loud. Okay, so let's reduce this a little more. So advanced, and we'll make this -6. Okay. Perfect. And without further ado, let's get into the games. Okay, and let me just turn down the volume here. Okay, so we'll just start with some simple levels. And I'm gonna go ahead, turn down the effects volume. Okay. So hopefully you guys can't hear that on the microphone. Let me just see if you can. Okay. Okay, so that's getting filtered out as noise. Alright, perfect. Alright. So yeah, we'll just be playing this game for a little bit. I'm actually very fond of this game. I played it quite a bit when I was a kid. And hold on, let me pop out the chat and stuff so I can see what's going on. Okay. So there's my game. And there's my chat. Perfect. Okay. So next level. Oh dear, remembering the project video of this game. Yes. That one was an interesting one.
Super speed.
I believe it was titled Gay Play or something like that. Something funny. Well, funny is subjective, of course. Something I thought was funny. We'll say that. Gem collection.
Time travel.
But yeah, welcome back, by the way,
Time
Lincoln.
travel. Time travel. Time travel.
Yeah, it's called Project Gameplay. Oh no, I haven't found all the gems. Hold on. I got a little distracted. Okay.
Time travel.
So we'll go up here. Grab that one. This one. Grab this time travel. Go over here. There we go. That was easy. And I just want to... Okay, so I do need to reverse my webcam here. Hold on. There we go. Flip horizontally. Perfect. So then when I'm looking at the screen, it actually looks like I'm looking towards the game and the chat. There we go. Alright. So I'm actually gonna go ahead and do some advanced levels, because I'm feeling like some pain right now. Yes, Uno reverse card has been applied. Oh god. I say, I'm in for some... I'm looking for some pain right now, and then I get the pain, and then I'm not so sure about whether I want it anymore. Oh dear. Okay.
Time travel.
No! Alright. Ah, shoot. A ball has fallen into the void in Ball City. So I'm actually gonna go this easier route over here. Ah, shoot! Okay.
Checkpoint.
Woo! So we got a bit closer that time, and we got, yeah, the easier path. Easier in quotation marks. Okay. At least we got a checkpoint, though.
Time travel. Checkpoint.
Ah, shoot. Do I risk it? Ah, I'm like, do I risk it? And then I, like, just whiff it entirely. Ah! I'm determined to get this, though. I want to see if I can float up here. Uh-oh. Yeah. Okay, there we go. Perfect. Alright, there we go. And we'll roll up here. Perfect. So that... I was about to say that was easy, but that was not easy, but we did it.
Checkpoint.
Woo! Oh no! I got really close there. Denied. Oh my god! That, I swear that didn't even hit me. Okay, there we go. Wait, are you seeing that? That one is like floating above the ice slightly. That's so funny. Yay! I did it. That one was easier than the first one. Let's go ahead and do some of the intermediate ones. I think that'll be more fun, I think.
Gyrocopter. Checkpoint.
Uh-oh. Okay. There we go. Oh, wow. That was really fast. Okay. I hate that level. I'm not gonna do that one. I should change the title of the stream, shouldn't I? Yeah. Why don't we go ahead and do that? Okay. So we'll do playing games and F# programming. Okay. And I'll change the category to gaming, and we'll do Marble Blast Ultra. There we go. Alright, perfect. Alrighty. So I'm gonna go ahead and restart the level now that I've wasted all that time, like, in-game speaking. Of course it wasn't a waste of time to change the stream thing.
Checkpoint. Checkpoint.
Oh, I missed the jump. Shoot. Oh my god. That keeps happening to me. There we go. That was more difficult than it needed to be. Alright, perfect. And Lanterni, how does the audio sound? I'm just wondering, like, can you hear the game that, like, I have my speakers on right now, just really low. Can you hear that at all? I'm just wondering, like, if that is a problem. Or if the noise cancellation sounds perfect. Okay, cool. There we go. This one's a fun one. It's interesting to think about how to get all of the gems in the fastest way possible. Oh, shoot. Uh-oh. There we go.
Checkpoint.
Okay. Gonna hitch a ride onto this one. Oh no! This one definitely is a tad bit harder than some of the previous ones. There.
Checkpoint.
Okay. So now all that's left is that last one. Now we have to wait for these slow platforms to do their thing.
Checkpoint.
Nice. Alright. Oh no! Okay. Oh, the finish is over here. Okay. Do I risk jumping on this? Yes. Nice. Hearing this music and remembering the time before time. Yes. In the time before time, the great spirit of Mananui was cast into a deep slumber by his brother Makuta.
Checkpoint.
I almost fell there.
Checkpoint.
Okay, what the heck is happening? I can't even tell where I am. Ah! Okay. Oh no! Oh. Shoot. Okay. Let's try that again. Okay, there.
Super jump.
Ah, shoot! I had it, and then I wrecked it by... Okay. That's frustrating. Is this bad level design? I feel like this is bad level design. Just like... basically RNG
Super
equivalent.
jump. Super jump.
Okay, there we go. Alright. We'll do just a couple more here, then I will get back to writing some code. True, I suppose. Yeah, that's true.
Checkpoint. Time travel. Time travel.
Oh crap! I was expecting something to be there that wasn't there. Does this take me all the way up? No. So this goes down. Does this go up? You'll have dinner now? Okay, sounds good, Linterny. I will enjoy this stream, and I hope you enjoy your dinner. Bye-bye! Alrighty. Let's see, which one do I get onto? This one. Ah, now this one. And now this one. So then which one next? I suppose this one. And does that take me to the top? Oops, I missed that one. Okay. There we go. Okay.
Checkpoint.
So now we have to wait for that one to come down. There we go. And we're almost through the level. Nice. Alright, awesome. So, I actually think, how long have I been streaming for? Let's see. I've been live for a bit longer than that, I thought. Let's see. Oh, okay. So, yes, I have been streaming for about an hour and a half. So, I believe I will be stopping the stream. Thank you everyone who is watching this either after the fact or who did come in and watch. Thank you for watching the stream. And yes, I will see you all next time. Bye-bye!